The newest measurements of the interstellar object 3I, Atlas, have revealed something that no one was expecting. When astronomers analyzed the gas surrounding this object, they uncovered isotope ratios that were unlike anything seen in our solar system. These ratios act like chemical fingerprints that tell scientists where and when a piece of matter formed. What makes this discovery so striking is that the gas released by 3I, Atlas, contains an unusually high amount of deuterium compared to hydrogen. Along with strange ratios of carbon and nitrogen isotopes, these numbers are so different from what we expect that they suggest the material may have formed in a much colder and older environment than most planetary systems we know of. The deuterium to hydrogen ratio is the most intriguing part of these findings. Deuterium is a heavier version of hydrogen that contains an extra neutron, and in most parts of the solar system, the ratio of deuterium to hydrogen remains fairly stable. Earth's oceans, for example, have one ratio, while comets from the outer solar system have slightly higher values. However, the gas measured around 3I, Atlas, shows a deuterium to hydrogen ratio that is more than 10 times higher than what astronomers typically observe. This immediately suggests that the object may have formed in extremely cold conditions, likely well below negative 200 degrees Celsius. Such low temperatures would allow deuterium to accumulate in water ice over long periods of time. But the surprises don't stop there. Carbon isotopes in the gas surrounding 3I, Atlas, provide even more unusual clues. Carbon exists in two main forms, carbon 1,2 and carbon 1,3. In most stars and planetary systems, the ratio of these two isotopes stays fairly stable because they are produced by the same processes inside stars. However, measurements from 3I, Atlas, show a much higher ratio than what is typically observed in materials from our solar system. This suggests that the carbon in this object may have formed in a different kind of stellar environment, potentially much earlier in the history of the Milky Way galaxy. The nitrogen isotopes detected in the gas add another layer to the mystery. Nitrogen, like carbon, exists in two forms, nitrogen 1,4 and nitrogen 1,5. The ratio of these two isotopes in the gas around 3I Atlas doesn't match the nitrogen found in Earth's atmosphere, meteorites, or known comets. When scientists combine this unusual nitrogen signature with the strange ratios of carbon and hydrogen, they end up with a chemical pattern that doesn't fit well with standard models of planetary formation. This leads some researchers to believe that 3I, Atlas, may have formed in an ancient part of the galaxy, where early stars contained fewer heavy elements than the stars we see today. If 3I, Atlas, did indeed form around one of these early stars, it could be a fragment of a planetary system that formed 10 to 12 billion years ago, during a time when the Milky Way was much younger. This would mean that 3I, Atlas, could be carrying chemical signatures from an era long before the solar system formed. However, this theory raises another problem. Early stars contain fewer heavy elements, which are essential for forming solid objects. But the number of interstellar objects passing through our solar system suggests that large amounts of material must have been ejected from many star systems over time. When scientists estimate the amount of mass needed to produce this many objects, the numbers appear to be extraordinarily high, pointing to an origin that current models of galactic chemistry struggle to explain. The strange isotope data surrounding 3I, Atlas, is just the latest chapter in the growing story of this mysterious interstellar object. Since it was first detected by astronomers using the Atlas Sky Survey system, 3I, Atlas has been a subject of intense study due to several unusual characteristics. Astrophysicist Cosmotech has been one of the most vocal researchers examining the object. Over time, he has compiled a list of 18 different anomalies associated with 3I, Atlas. Some of these anomalies seem to fit into a category that could be described as geometric coincidences. One of the first things astronomers noticed about 3I, Atlas, was that its orbit appears to be surprisingly aligned with the general plane of our solar system. Most planets in our solar system orbit the Sun in roughly the same flat plane, but interstellar objects are expected to come from random directions. The fact that 3I, Atlas's trajectory, lies relatively close to this plane is certainly unusual, though not impossible. Even more curious is the path it takes near Jupiter's orbit, the largest planet in the solar system. Jupiter has an enormous gravitational influence that extends far into space, and astronomers measure this region using something called the Hill sphere, which is the area where Jupiter's gravity dominates over the Sun's. The projected path of 3I, Atlas appears to pass near this gravitational zone, which could mean that Jupiter's gravity will play an important role in shaping the object's motion as it continues on its journey. Another geometric coincidence involves 3I, Atlas's alignment with Earth and the Sunday. At one point during its approach, the geometry of the orbit placed the object nearly along the line connecting Earth and the Sunday. During this time, a feature known as an antitail, a structure made of dust particles pushed by solar radiation, appeared to point roughly toward Earth. While antitails are not unheard of in comets, the specific geometry required to see them clearly from Earth is relatively rare. The arrival direction of 3I, Atlas, has also attracted attention because it lies not far from the region of the sky associated with the famous WOW signal detected by radio astronomers in 1977. This signal was a brief burst of radio energy that has never been fully explained, and the proximity of the two directions adds another layer of intrigue to the discussion surrounding 3I, Atlas. But it's not just the orbit and alignment that have researchers puzzled. Observations of 3I, Atlas's jets, provide another geometric puzzle. As the Sun hits the surface of icy bodies, gas can escape through cracks or vents, producing narrow streams of material known as jets. Images of 3I, Atlas, suggest that some of these jets point roughly toward the Sunday. Even more intriguing is the fact that similar structures appear both before and after the object passes its closest point to the Sun, creating a mirror symmetry in the pattern of outgassing. In addition to these geometric oddities, the composition of the gas released by 3I, Atlas, has raised additional questions. Spectroscopic studies allow astronomers to identify the elements present in the cloud of material surrounding the object's nucleus. In this case, some measurements suggest an unusual abundance of nickel relative to iron. Most comets and asteroids contain these elements in more balanced proportions as they form from the same mixture of material in the early solar system. A higher nickel-to-iron ratio could indicate that 3I, Atlas, originated in a different chemical environment. The overall mixture of gases around 3I, Atlas, also appears somewhat different from what scientists typically expect in comets. Water vapor is usually the dominant component of cometary outgassing when an icy body approaches the Sunday. However, some observations of 3I, Atlas, suggest that carbon dioxide and other carbon-bearing molecules may play a larger role than water in driving the activity. While this doesn't mean that the object contains no water, it does suggest that the balance between gases might not match the patterns seen in many familiar comets. Dust structures around 3I, Atlas also behave in unusual ways. The antitail observed from Earth appears unusually narrow and extended. Dust particles released from the surface interact with solar radiation and the solar wind, sometimes creating complex patterns. The exact shape of these features depends on factors such as particle size, velocity, and the direction of the comet's motion. As a result, the dust geometry around 3I, Atlas, has become another topic of detailed study. Beyond chemistry and geometry, astronomers have also noted several unusual physical properties of 3I, Atlas. Estimates of the size of the object suggest that its nucleus may be relatively large compared to other interstellar visitors. Its velocity as it moves through the solar system is also quite high, which is consistent with an object that likely originated far outside the sun's gravitational influence. While these characteristics alone do not make 3I, Atlas, extraordinary, they add to the growing list of features that researchers are examining. One particularly interesting observation involves the polarization of light reflected from the object's dust cloud. Polarization occurs when light waves vibrate more strongly in one direction than another. By measuring polarization, scientists can learn about the shapes and sizes of dust particles in the cloud. Observations of 3I, Atlas indicate unusually strong polarization signals compared to typical comets, suggesting that the dust grains may have different structures or compositions. Brightness changes near the sun have also attracted attention. As icy bodies approach the sun, they typically brighten gradually as more material begins to vaporize. However, 3I, Atlas, appeared to brighten rapidly over a short period of time, which could happen if fresh ice was suddenly exposed or if jets began to erupt from the surface. The exact cause remains uncertain, but it has become another feature that astronomers are monitoring closely. Measurements of the object's motion indicate slight deviations from the path expected from gravity alone. This effect, known as non-gravitational acceleration, is common in comets because jets of escaping gas can act like tiny rocket engines. When gas streams out in one direction, it produces a small push in the opposite direction. In most comets, these forces are relatively easy to model. However, for 3I, Atlas, scientists are still working to determine exactly how the outgassing is influencing its trajectory. All of these observations are becoming increasingly important as 3I Atlas approaches a key moment in its journey. On March 16th, the object will make a relatively close pass near Jupiter. Jupiter's immense gravitational field will exert a strong influence on the object's path, and even a small change in trajectory caused by this encounter could reveal new information about the mass and structure of the nucleus. Jupiter's environment is very different from the rest of the solar system. The planet has an enormous magnetosphere filled with energetic charged particles. If the gas and dust surrounding 3I, Atlas interact with these particles, astronomers may detect changes in the comet's tail or observe new emissions. These effects could provide important clues about the composition of the material. At the same time, telescopes around the world will be watching closely. Scientists will track 3I, Atlas's position, before and after the encounter to refine its orbit. Spectroscopic instruments will continue analyzing the gas cloud, and high-resolution images may reveal new jets or dust structures that were previously too faint to see. The upcoming Jupiter encounter represents a crucial moment in the ongoing study of 3I, Atlas, as it may shed light on many of the mysteries that still surround this object. For now, the new isotope anomaly has only deepened the puzzle. The unusual chemical signatures suggest an origin in a cold and ancient part of the Milky Way, but explaining how such an object formed and traveled here remains difficult. As March 16th approaches, astronomers are eagerly awaiting the Jupiter encounter, hoping it will reveal new insights into the true nature of 3I, Atlas. Whether this object turns out to be an unusual but natural comet or something that challenges our current theories of planetary formation, it has already reminded scientists that the galaxy still holds many surprises. Keep watching as more data comes in and the mystery of 3I, Atlas, unfolds. If you're fascinated by the unknown and the mysteries of space, don't forget to like, subscribe, and hit the notification bell so you don't miss out on the latest discoveries in the universe.